to now, when using the compound interest formula, we have always had an annual interest rate, I, over a number of years called t here in the power. So a equals p into 1 plus I to the power of t is always based on a unit of time, which is the year. Now we're going to change that unit of time to months, because that's what we often need in calculations, as you're going to see shortly as well. So let's start. Imagine you start off on, for example, the 1st of January with an amount P that you want to save. That's your present value or your starting amount. What's that worth after 1 month? Well, let's say the monthly interest rate is IM, whatever that is. That's what we're trying to find actually, but let's call it IM for the moment. Well, after 1 month, your amount P is worth 1 times your money plus IM times your money. So at the end of the first month, your money P has grown to P into 1 plus IM to the power of 1, according to the compound interest formula. Now, after 2 months, what happens? Well, your new starting amount is what you finished up with the last time, which is in red here. So now after 2 months, your money is worth 1 times that plus IM times that again, which works out to be 1 plus IM by 1 plus IM, which is of course P into 1 plus IM squared. So after 2 months, your money is worth that. Now after 3 months, if you use the same logic, it's 1 plus IM cubed, etc. So we get this formula. If you move on to after 12 months, the formula becomes your final amount at the end of 12 months is worth P into 1 plus your monthly rate to the power of 12. Now we can have another look at our final amount of money. We started off with P, we'll say for example on January the 1st again, and on December the 31st of the same year we end up with A, our final amount, our final value. So we can look at that 2 ways. We can say that our amount P, it grew to an amount A, 1 plus I to the power of 1 if you use an annual interest rate, because it's I is the annual interest rate and the 1 represents 1 year. Or you can equally say, well, my starting amount P amounted to 1 plus IM to the power of 12 by P if I work in months with a monthly interest rate. And obviously you end up with the same amount of money, whether you work in units of time of years or months. It's the same amount you end up with at the end of 12 months anyway, A. So this A, if you're working in years, is P into 1 plus I to the power of 1. Or if you're working in months, it's P into 1 plus the monthly rate to the power of 12. So again, let's emphasize this first I here is a yearly rate to the power of 1 year. And this is a monthly rate to the power of 12 months. But they're both the same thing. Now, the starting amount is the same on both sides of the equation, so that just cancels, the P is gone. And now you have 1 plus I to the power of 1. Again, I representing the yearly rate is 1 plus IM to the power of 12 over here. We now need to work out what IM is. That's what we're looking for, the monthly rate. So we can get both sides to the power of 1/12. And what that does is it cancels the 12 here, because you multiply the powers. 12 by 1/12 is 1. But you must do the same on the other side, obviously, 1/12. And now the power is gone, so we can actually get at the IM, which is what we're looking for. And we can now take the 1 across as a minus, and we finally have a formula for the monthly rate of interest. So it's 1 plus the yearly rate, or the annual rate, to the power of a 12th minus 1. And this is a formula you have to know really. There's one like it in the tables, but it's not quite the same formula. So you need to really memorize that formula, a very important formula, because this calculation turns up over and over again in the exam papers. So monthly rate formula, IM. Now, if this was a weekly rate, for example, you just change to 1 over 52 because there's 52 weeks in a year. Or, for example, if it was a quarterly rate, IQ, we'll call it, the quarterly interest rate, is 1 over 4 in the formula. Okay, so let's keep that formula in mind for all the examples that are to follow. Now, this next example, we're going to show you how a savings plan works. So this is how you'd lay out your savings. If you're saving money at a regular period, you're putting in the same amount at the same time every month or every year, whatever it is. So we'll start off simple with just putting the same amount of money in once a year. And what we want is here in this example, we want to end up with a savings of 5,000 at the end of 5 years. So we want to end up with this 5,000 here. Now, so we're kind of working backwards in this example. We need to put in this amount P every year for 5 years to end up with 5,000. So what should this amount P be? Now, you can think, just keep it simple first. Imagine there was no interest. Well, obviously, you just put in 1,000 each year because 5,000s would give you 5,000. But in reality, there is interest. So that means you don't have to put in quite as much as 1,000, because if you put in less, it's going to grow in value anyway. And so whatever this P is, it's obviously going to be less than 1,000 each time, because with interest, it's going to grow to 5,000 when you add all those future values together of your money. So let's work this out mathematically then. Your first lump of money that you put in the first year, P. So this is going to be the key, actually. Let's treat every lump of money separately. So that first P. So the key is to treat it separately to all the others. What does that grow to? Well, after 5 years, it grows to P times 1 plus I to the power of 5. That's just the compound interest formula. 1 plus the interest rate to the power of 5 years. And this is the annual interest rate. We're ignoring months for now. We're just keeping it simple for a start. Now, the second year, your money was only there for 4 years. It's gathering interest. So that P, if you bring it to the future, it gathers a future value of P into 1 plus I to the power of 4. And the next one, 3, and so on. And up to the final example, the final amount P you put in for 1 year. So that grows to P into 1 plus I. So that's only 1 year's interest it gathers before you take all your money out again. Now, all these future values of your money, if you add all those together, well, that should add up to 5,000. That's the idea. So these are your original amounts with their interest added on. All added up together should add up to 5,000. Now we take this sum, this vertical sum here, adding all that column, and write it horizontally. It's easier to work with horizontally down here. So here we have it again, P into 1 plus I to the power of 1, P into 1 plus I squared, etc., all the way up to P into 1 plus I to the power of 5, and they should all add up to 5,000. Now, if we keep going here with the algebra, we've got P in each term here. If you look at all the major terms here, P is in front. So take out the P, take out what's common outside the bracket, and now inside the bracket it's a bit simpler. So you still have 5 terms, 1, 2, 3, 4, 5 terms here. At this stage, we put in our interest rate. Now, in the example I picked here, I just said keep the interest rate simple, keep it as 10% or 0.1. And now you put in 0.1 for I. So now it's 1 plus 0.1, and of course that's 1 plus 0.1 is 1.1. So now it becomes much simpler again. Your P is still outside the bracket, but now you have 1.1, 1.1 squared, etc., up to 1.1 to the power of 5. And again, all of those added together, multiplied by P, is 5,000. Now the next thing to spot is this is where we connect with another part of our course, sequence and series. And we should spot at this stage that this is a geometric series. And that means that each term is multiplied by a constant number to give you the next term. That number is called the common ratio, R. So just looking at this, for example, the first term is 1.1. Multiply that by itself, 1.1 by 1.1, you get 1.1 squared. By 1.1 again, you get 1.1 cubed, etc. And that's the definition of a geometric series. When you can multiply by the same number each time, that's a geometric series. Now, the first term is always called A. So 1.1 is A. Now, R, the ratio is also 1.1 because we're multiplying by that same number each time to get the next term. So A and R are the same. N is 5, that's the number of terms. So there are 5 terms in this sequence here, this series. Now, once you have those 3 letters, you can just sub them into the formula, which is the sum of a geometric series. It's in your maths tables. So the formula is here, A into 1 minus R to the power of N over 1 minus R. You fill these 3 in. So there they are filled into the formula here. And you work it out on your calculator and we get the answer of 6.71561. And don't forget there's still a P outside the bracket. So we've just worked out what's in the bracket here. What's in the bracket works out to be 6.71561. So P times that is 5,000. P times what's in the bracket is 5,000. So divide across by Sn. And P is now 5,000 over our answer. And you finally get your answer of 744.53. So all those amounts P that you put in, they were 744 euros each time, which is, as we expected, less than 1,000. So we paid in 744 5 times. So 5 times 744 is 3,000, whatever, 3,000 and something. So you're obviously making interest of over 1,000 to get to 5,000, which is your actual savings in the end. So that's the first example. Now the next example is we're going to take those same figures and we're going to change to monthly payments instead of yearly payments. Because again, let's face it, nobody really does this. It doesn't happen very often. We pay in once every year, an amount of money. We tend to live our life, I suppose, month to month. We get paid per month, usually, or per week or whatever. So let's imagine the same thing. I want savings of 5,000 at the end of 5 years, but I'm going to pay in every month instead of every year. So what should P be now? What should my payment be every month to end up with 5,000? Now, clearly that changes things. Everything is now in months, not in years. So the 5 years becomes 5 by 12, which is 60 months. Also, the interest rate has to be converted to a monthly interest rate using the formula that I just showed you earlier. And by the way, you can't simply divide by 12 to get a monthly interest rate because compound interest doesn't work like that. It grows exponentially. So it gets bigger and bigger as the months go on. So it doesn't divide evenly into 12 equal blocks. So you can't just simply divide by 12. You have to use that formula that I derived earlier for IM, the monthly interest rate. So let's do that. So two changes. It's basically a change of unit. The 5 years must be changed to months, which is 60 months. And the interest rate, annual interest rate, must be changed to a monthly interest rate. And that's what we're doing down here in the second example. So we're taking the 10%, which is 0.1. We're putting into our formula for IM. So there's the formula IM. And if you work out the formula, put in your 0.1. So it's 1.1 now to the power of a 12th minus 1. Put it into your calculator and you get the answer for the monthly interest rate, 0.007974. And as I said, the time becomes 5 years by 12, which is 60 months. So if you go back to your sequence here, back to where we were earlier, there are now two changes in this. First of all, it's not 5 years anymore, it's up to 60 months. So that becomes up as far as 60 instead of 5. Secondly, the interest rate, instead of being 0.1, which is 10% per year, it's a new rate per month. So those two things change. So watch, if you come down here again, those two things change. The interest rate here and the power here. So there they are. The interest rate has changed from 0.1 to a monthly interest rate of 0.007974. And the number of months has changed. So it was 5 years, now it's 60 months. So now there are 60 terms in our sequence. 60 terms. So that means that our first term, well, our first term again is still A, we call it A. It's 1.007974. Now multiply that by itself and you get the second term. By itself again, you get the third term, etc. So that hasn't changed either. So A and R are still the same. And the number of terms is 60. There are now 60 terms instead of 5. One for each month. And now you fill those into your formula. You fill in your new A, your new R, and your new N, of course, which is 60. You fill all those in, and you get an answer of 77.17139. Again, there's a P outside the bracket. Don't forget about that. So P by our answer is 5,000. So 5,000 divided by our answer is P. So 5,000 divided by this answer here gives us P. So our monthly payments are 64.79. So the monthly payments, if you did it out in months, if you did it scheduled out in months, each of these would be 64.79. So one more example. So recall again, in that last example, we worked backwards. We knew the total savings we wanted. It was 5,000. And we worked backwards to get the amounts you put in, P. Now this is the reverse. Now we have the amounts this time, 1,000. And we want to find out what the savings are. So the last time we were kind of working backwards, now we're working forward. So if anything, this is a bit easier. So let's work it out. A bank offers a savings account with a percentage, an AER of 3%. So that's your annual interest rate. And a customer deposits 1,000 every year for 10 years. How much will you have at the end of the 10 years? Okay, so let's put in the first 1,000. Well, that's going to gather 10 years interest. So come along here. 1,000 into 1.03 to the power of 10. There's your compound interest formula again. Just fill it in. 1 plus 0.03 to the power of 10. And your present value, your starting amount of your money is 1,000. Now the second 1,000 you put in the second year, that's only there for 9 years. So they're 1 year less. So it's the compound interest formula again, except it's to the power of 9. Your third 1,000 is there for 8 years, gathering interest. 1,000 into 1.03 to the power of 8, etc., all the way down until the very last payment on the 10th year. 1,000 goes in for 1 year before you draw it out again. So it's 1,000 into 1.03 to the power of 1. And now all these future values of your money, when you add them together, that will give you your total savings. So your total savings is, if you just arrange this sum horizontally, it's easier to work out. So write down this vertical sum horizontally and you get 1,000 into 1.03 to the power of 1 plus 1,000 into 1.03 to the power of 2, etc., up to 1,000 into 1.03 to the power of 10, the last one here. So we go from here up to here. And that gives you the total savings. And now just take out what's common. There's 1,000 everywhere. So take that outside the bracket, take it out what's common. And inside the bracket, we just have 1.03 to the power of 1 plus 1.03 squared, etc. So we have 10 terms again. The first term, yet again, is the same as R. 1.03 is the first term. Multiplied by itself, you get the second term. Multiplied by itself, you get the third term. So A and R are the same as usual. The number of terms is 10. Fill into your formula, and you get 11.80, etc. Yet again, there's still 1,000 outside the bracket, so don't forget to multiply by the 1,000. And 1,000 by your answer gives you the total savings, which is 11,807. That's the answer. So again, we paid in 1,000 10 times, which is 10,000 we paid in altogether, and we ended up with savings of 11,807. So our interest was over 1,000. Obviously, it was about 1,807 was our total interest. So that's the final example, and that's the end of this session.